You know this sound. You place your favorite snack on the grocery store counter, the cashier slides it across a glowing red laser, and beep. If you pick up that snack and look closely at what triggered that sound, you'll find a little block of black and white stripes. To our eyes, those lines are a mystery. We can't read them. They're just a random pattern on a label. In technology, we call those lines data, a collection of raw facts. On its own, it doesn't tell a story. But a barcode reader processes this data instantly, translating those mystery lines into a useful description, the snack's name and price. Once data is processed into something meaningful, it becomes information. It's knowledge that we can understand and act on, like paying for our treat. That invisible moment, taking a raw fact and turning it into useful knowledge, is the essential building block of our digital world. This translation happens everywhere, even in places you might not expect, like a library. Flip over any textbook, and you'll find an ISBN code. Like the barcode on a snack, these numbers are raw data. A computer uses them to identify the book's title, its author, and exactly which shelf it belongs on. These systems are called Information and Communication Technology, or ICT. Think of ICT as an engine that takes raw data, processes it into information, and communicates it, like instantly telling the warehouse to order more snacks, keeping shelves full. ICT is the continuous process of exchanging information to drive decisions that keep our world moving. Because we rely on this information to make choices, the quality of that information is vital. Flawed information leads to poor decisions. For example, information must be accurate. A doctor relying on incorrect health data could prescribe the wrong medicine, leading to serious harm. It must also be timely. An accurate weather report from 3 days ago is useless when deciding if you need an umbrella this morning. Relevance matters too. If applying for a corporate job, your first-grade report card is a true fact, but isn't the information the employer needs. Finally, information must be complete. A government cannot understand a nation's wealth by only looking at a small group of people. Without the full picture, they will make the wrong choices for the economy. When information is inaccurate or incomplete, it directly impacts our lives. High-quality data is the requirement for a functioning society. This exchange of high-quality information manages our global systems, from how we grow our food to how our governments provide services. But these massive processing systems have recently turned their attention toward our own everyday actions. Most of us now carry a highly sophisticated data collector with us everywhere we go. It's your smartphone. Every time you use GPS for directions or scroll through a social feed, you generate a trail of raw data. Much like a scanned barcode, your movements and habits provide the facts that computers process. We have reached a point where our daily lives have become the very data that fuels the global ICT engine. Your devices process your habits to generate specific information about your routines, your location, and who you talk to. Because these devices are constantly communicating this information to remote data centers, our individual privacy is a constant concern. Part of being a student of technology is learning to protect your digital footprint. Your personal data deserves the same protection as your physical belongings. If we return to the familiar supermarket checkout, we can clearly see the entire system working on a global scale. The beep of a scanner represents the constant, invisible conversion of raw data into the information that runs our modern lives. Take a look at your own phone. What raw data are you creating right now, and what information will it ultimately become? Think about how many times you interact with a screen or a scanner every single day. Every time you swipe a card, tap a screen, or press a button, you're starting an invisible digital chain reaction. But even though we are surrounded by these devices, what is the actual job they are doing behind the scenes? At their core, every single one of these machines is built for the same purpose. A computer is simply a system designed to take one specific thing and convert it into something else. Specifically, it takes in data and transforms it into information. Knowing the difference between those two words is the first step in understanding how any computer makes sense of the world. Take a look at this scene at a grocery store checkout lane. Notice the cashier sliding a can over the electronic scanner. When that scanner beeps, it isn't reading the word water on the label. It is only looking at the barcode, that simple pattern of black and white lines. To us, those lines are just a meaningless pattern. That is exactly what data is, raw numbers or signals that don't have a clear story to tell yet. It's like seeing the numbers 55, 45, and 85 written on a blank wall. Without knowing if those are ages, prices, or test scores, they are just isolated facts that we can't use. Data is the raw material. Think of it like a pile of unbaked ingredients sitting on a counter. A system has to collect those ingredients before it can do anything for us. But what happens if that barcode is ripped? The automated scanner can't read the lines, meaning it can't collect the raw data it needs. This is where the keyboard comes in to manually feed the system data. A typist rests their fingers on the middle section, the home row. From here, they can easily reach any keys needed to type a product's ID code. When you press those keys, you are sending the exact same raw signals into the machine that a laser scanner would have sent. Whether we use a laser or our fingers, the goal is the same. We are providing the input that gives the system its raw data. Once that raw data is collected, it leaves the scanner or the keyboard and travels deep into the computer's internal system. This is the processing phase, where the computer calculates or organizes raw facts against a master list. Looking at those numbers 55, 45, and 85 again, the computer adds and divides them to find a clear average of 65. At the supermarket, this processing is how the computer matches those barcode lines to a specific item, like water, and a specific price, like 65 rupees. Processing is the translation step that turns those isolated facts into a result we can actually use. Finally, the system delivers that result back to the physical world, like a printer spitting out a receipt. That receipt contains information. This is data that has been fully processed, so that it now has a clear meaning and a purpose for the person reading it. It's the golden rule of computing. Raw data goes in as input, it gets processed, and meaningful information comes out as output. But there is one last twist. The terms data and information depend entirely on who is looking at them. Your printed receipt is information to you, but to the store manager, 1,000 of those receipts are just raw data to be fed into a new system to calculate the store's monthly profits. Every time you type a key or scan an item, you are launching that journey from data to information.